All right, welcome everybody. Welcome to tonight's webinar with Christina Tundebold. Christina is going to tell us all about, or enlighten us about, subtraction fluency, and how we help kids overcome the challenges that they have, because we know that operations, addition, subtraction always can provide challenges for them. So a couple of things before we get started. So for attending tonight, we are giving you a free class license on a trial basis. You just go to our website, brainingcamp.com, click on the redeem code, enter the code subtraction22, and this gives you a class license for 60 days. So you get an account for yourself and for all your students. You must redeem that code by January 31st. So I want to just take a moment just to walk through a little bit on the redemption process. So here we are on our website. Here's the redeem code. Now this is if you have never had a Brainingcamp account before. Click redeem code, enter in subtraction 22. Hit submit, and it'll ask you a few questions. I believe it'll ask you for your email address, and then you should be good to go. Now, if you already have a Brainingcamp account, you can just sign in. Even if your license is expired, sign in, and then you'll be prompted to enter the code subtraction 22. One more thing. As we go through tonight, Christina is going to be talking about using the term share code. And so as we go through this evening, you'll see up here, when Christina talks about entering your share code in the share code box, that's where she's talking about up there. So now I've got to erase that. There we go. I don't want that to be in the way for tonight's presentation. Tonight's webinar will be recorded, and we can we'll put that information in the chat. It's on our website. It should be posted within about 48 hours that you'll be able to access the recording. And so now I feel like there should be a drum roll. Now I want to introduce to you our presenter for tonight, Christine Tundebold. Christine's the facilitator and founder of Build Math Minds website. And if you go there, you'll find plenty of resources for math instruction, for professional development. She's got a blog about issues related to math education. And there's plenty of other resources, ready to use resources, or just a resource for your own personal learning. She's a former middle school math teacher who is now laser focused on helping teachers on their own journey so that they can move from a drill and kill type teaching, or remote type instruction, rote instruction, to a more conceptual approach. So with that, I am going to stop sharing my screen, and Christina, it is all yours.
Awesome. Thank you so much for that nice introduction. And our plan is to really talk about, hold on one second. Oh, I hate when this happens. I wanted to be able to see the chat, and for some reason it disappears on me. There it is. Okay. I'll try not to get too distracted with the chat, but I want to make sure that it is up and ready in case I want to be able to look at when I ask questions. The chat can be distracting, but at times I do want to see what you guys have to say in here. So we do have less than an hour to talk about a very complex concept in mathematics, which is subtraction. So we are going to talk about 3 things that can help students who are struggling. And to be honest, all of our students are struggling with subtraction. Subtraction and division are some of the biggest ones that kids struggle with. So I'm just going to give a little tip of the iceberg, and we're going to show some of the ways that we can use Brainingcamp to help us out. And don't forget to check the chat area to grab that code so that you can participate and get in there and play around with the apps as we are focusing on how to help kids with subtraction. So 2 of these popped up. Apparently I have my animations correct. So the first one we're going to dive into is using visuals and models. The second one is looking at subtraction problem types. And then the third one is connecting addition to subtraction. These 3 things are not the end all be all that will help kids finally understand subtraction. They are the top tips. They are the things that I have found to be the most successful, not only with students, but with my own understanding. I was very traditional in my teaching and in my own learning. It was just memorizing a bunch of rules and steps and procedures. And it wasn't until I was an adult and started my teaching journey that I realized not everyone learns that way. And when I started delving deeper into how kids actually think about and learn mathematics, it changed my own understanding of mathematics. And these 3 things have helped a ton for me personally as well. So let's dive into the first one, visuals and models. So I want you to think about the problem. And let me rephrase that. I didn't say it quite right, but I want you to visualize 2x plus 3 equals 31. 2x plus 3 equals 31. And if you feel comfortable, type in the chat area what was in your brain. When you visualize 2x plus 3 equals 31, tell us in the chat what came to mind. Okay, what was in your brain? Put that down on paper, type it in the chat. Okay. Oops. Sorry about that. Let me turn off my alarms and reminders while you're typing that into the chat. So the first one I saw was just symbols and numbers. I also saw someone say a balance. So like back to back, 2 very different ways to think about and visualize that problem. Someone is seeing it as a balance and someone is just seeing these symbols on a piece of paper, which as I am seeing what you're putting in the chat, I see a lot of the symbols and even the procedure, the steps, like you take away 3 from 31, you divide by 2, that's the visualization that we have for 2x plus 3 equals 31. Now, don't get me wrong, there were some of you who did put some visuals in there. And this is a time that I'll remind you, if you want everyone to see what you are typing in that chat area, make sure to click that drop down because some of you are just sending to the hosts and panelists, which means just myself and Brainingcamp can see those, okay? So if you want everyone to see it, which maybe you don't, that's totally fine. Just change that drop down to say everyone. So a lot of people put the 2x plus 3 equals 31, which is the way we all learned it, right? It's algebra. And I know you guys came here for subtraction, but this is to make a point, is that a lot of mathematics is not learned visually, especially algebra as we got into more in-depth stuff in middle school and high school. Most of you who are here, you're elementary because that's where subtraction is for the majority of time. So you have seen the power of visuals, but I really wanted to hit home this fact that visuals make such a huge difference in all parts of mathematics. Okay, so here's a visual that is pulled from this idea of something called SPLAT that Steve Wyborny has shared. Steve, Perrin said it. And so the spelling, if you see Perrin's in there in the chat, it's not an E in Steve Wyborny, it's just WY. But other than that, you can Google his name. It'll probably be one of the first things that comes up. This isn't one of his, but I took the idea of SPLAT because that is one of the first ways that I really saw algebra visually. A lot of people do talk about it as a balance, But even as adults, like it's hard for us to visualize large amounts of things. So as long as we can see groupings of things, then we're able to be able to visualize it, right? We can't hold a whole lot more than that. But the idea of splat is this idea that if you've never done this before, if there is a splat that is the same size, same shape, same color, underneath it is the same amount. So those of you who visualize 2x plus 3 equals 31, and you say, okay, we have to subtract the 3. Can you see there why you would subtract that 3, right? Thank you, Perrin, for grabbing the link and posting it in there. I really appreciate that. It helps to give people that quick one to be able to get there really quickly, right? And then why do we divide by 2? Well, because I have these 2 groups that are the same. I need to see how many is in each, right? So this visual is super, super cool. And the way that splat works is you eventually kind of reveal what's under those splats after you've had the conversations. I'm totally summarizing this because it's not like the main thing we're talking about, but that the visuals that we can help kids create make a big, big difference, right? So one of the things that we do really, really well is when we are teaching reading, right? The sign of a good reader is a visual. So I want you to close your eyes and visualize cat. Cat. Most of us, when we visualize cat, we are not picturing CAT, right? This is not the visual that you had. Maybe it was for some of you, but on this one, the majority of you had some kind of nice visual of a cute little cat, maybe your own personal cat, right? A cat from when you were a child, whatever it might be. You have that visual that you are connecting it to. The same is what we need to help kids create when it comes to mathematics, right? The visualize in your mind right now. I want you to actually close your eyes. And if you can see me on the screen, if you have the visual of me up, not just the screen, I was actually closing my eyes. I want you to actually close your eyes and picture 37. Picture 37. Okay. Can you picture 37? Can you actually visualize and picture 37 when you close your eyes? Okay. If you haven't done a lot of work with visualization, most of it is 37, the digits 3, 7, right? For those of you who do visualize something, I see one person has already posted in the chat. Now they're starting to all come through. I see a lot of, I saw 10 frames. I see base 10 blocks, right? I'm seeing 3 10s and 5 and 2. Annalise, of course, Annalise is visualizing Cuisenaire rods. Annalise is one of the queens of Cuisenaire rods. Elizabeth says, I'm picturing 3 dimes, a nickel, and 2 pennies, right? It is very, very rare that we can actually visualize 37 individual things, right? It's like your Rain Man, if you can do that. Our ability to hold an amount ends at 5, unless it is arranged in some way. The research on subitizing says that we can't subitize and perceptually subitize an amount larger than 5. After 5, it needs to be arranged in some way. That's why visualizing 10s is so important, right? A lot of you had visuals that related to some kind of 10. There are some of you who I saw the dozen of eggs and plus 1 more, like there's something that you connected that 37 to that was beyond 10s and 1s. But the majority of us see 37 as 10s and then some 1s. And that's the way it is for all of them. When we get into hundreds, you will see number of hundreds, 10s and 1s. Right? That ability to group things is what helps us be able to conceptually subitize, because we can't perceptually just instantly see 37. We have to see it in some kind of groups. Okay? That's why things like the Reck and Rec have become so popular. as you said, 10 frames, somebody did say they visualized it on a Rec and Rec, right? In order to see that amount, we typically have to group it in some way. All right. Now, one of the ways that we can help kids craft visuals is actually give them problems that elicit a visual image, right? We can't just expect them to conjure up images on their own. We have to provide problems that elicit some kind of visual imagery for them. So problems like this, where it's 37 minus 19, nothing there is making me want to visualize anything. All I'm seeing is some symbols, and it makes me just want to do a procedure. It doesn't create a visual picture in my mind. Now, we can do lots of things to help kids get there, but one of the first things that we can do is put a problem in context. So at the beginning of this, we asked people to start thinking about a story problem, putting some kind of contextual problem that involves subtraction in some way. So if you didn't already write one, I want you to try to write one really quick. Just jot it down off to the side. You don't have to share it in the chat. If you want to, you can. But I just want you to have it for at least you, because we're going to take a look at what kind of problem it actually is. So if you're not familiar with the problem types, we're going to do a very brief overview of it. Check our time here. I always plan more than we have time for, right? As all teachers do. So I'm just checking our time. Okay, so the problem types, you can Google the math problem types, okay? But I'll give you some examples here if you're not familiar with them. These are ones that I created, and I intentionally used the same person. It is John over and over and over again throughout every single one of these problems. It is about balloons in every single one of these problems. It is the same numbers every single time in these problems. You will see 12, 8, and 4 show up in every single one of these problems. Because one of the things that we want to take a look at is we don't want that distraction. Like, there are times when we vary it. For the majority of time, we vary it. But for our looking at this, we want to only pay attention to the mathematics that is different. When you are wanting kids to pay attention to the structure of a problem and how the problem changes, if you change the person who's involved in it, the context that's in it, the numbers that are in it, there's so many things changing at once that kids can't pay attention to the one thing you're really wanting them to pay attention to. And as adults, we can't. So everything in this example is all the same person, context, numbers. And the only thing that is changing is the situational type, the action or no action that's happening, and then what is unknown in every single one of these. This chart originated with cognitively guided instruction. Cognitively guided instruction. If you're not familiar with that, you can Google CGI math. Don't just Google CGI because you get a lot of computer generated, all that kind of stuff. But CGI math, cognitively guided instruction math, was kind of the founding people of these different problem types. Now, with the inclusion of Common Core here in the United States, they have taken this and added in a few different variations of things. But this is the base of all addition and subtraction problem types, okay? And Catherine asked, can we get a copy of this graphic? I would take a screenshot of it real quick. You can also email us. And Mark, I can't remember, do we share the slides with this? I can't remember what we do.
No, we don't, but
Okay.
we've got contact information at the end.
Okay, so you can reach out and we can get you this. So this is it for whole numbers. I also have one for fractional amounts, right? Some of you work with grade levels where you're working with fractions. It does not matter the number size. Addition and subtraction problem types are the same. This is the base. Now, of course, you might have multi-step problems, anything like that, but these are the base problem types, and they apply no matter what number sizes you're using. So if you work with fractional amounts and you've never really thought about all the different ways that you can write problems with fractions, then take a look at this one, take a screenshot. This one, I will tell you, doing with fractions is a bit more difficult. As you can see, I had to change my context a few times through. I still use the same numbers. I tried to use John over and over again, just to have that consistency. But I first started out with miles and then realized it's a little hard to do some of these problem types with that context. Okay, so some of it does change just because it became hard to write some of these problem types in that way. So again, these two, I'll bring these back up, but one of the things I want you to think about, and I'll flip back and forth between whole number and the fractional amount, is I want you to look at the story problem you wrote. Look at the story problem you wrote and see if you can figure out which problem type it is. And if you've never used this chart, again, it's kind of, like a coordinate grid, right? So if yours is similar to that top one in the left-hand corner, that's a join with the result unknown. So the one where John ran 3.5 miles, he walked for 4 3/4 miles. How many miles did John go? That is where you're joining amounts together, but the end result is unknown. And then if you go over to the middle one in that top row, it's the same context. We're still joining the amount he ran and the amount he walked, but it's a change unknown because something happened in the middle of the problem that we don't know. Okay, so take a little bit of time here, read through them. I'll hop back over to the whole number one. Sometimes that's a little bit easier to understand just because our mind sometimes shuts down when we have to deal with fractions. So I'll put the whole numbers back up here. Okay, so take a look at these problems, see if you can figure out which problem type yours is. Yeah, and it just scrolled past me. There it is. Margaret mentioned that we all need awareness of these problem types, as even in the upper grades. So the problem types are foundational for us. Kids don't need to know the names of these problem types, but we should as educators, because we have to make sure that kids are being exposed to all of these problem types. And one of the things we're going to talk about is one of the reasons that kids struggle with subtraction is because they don't get enough exposure to a certain problem type in here. They only, or not only, but the majority of their exposure is one type of this. And sometimes they're exposed to something that can be solved with subtraction, but really isn't a subtraction situation. So it's really important that we understand these problem types and know what they are so that we can ensure our students are being exposed to all the varieties so they get a full understanding of addition and subtraction. Yeah, and Margaret says, what about middle school? There's a lot of educators in middle school and high school who are really advocating for cognitively guided instruction and that every educator learn about cognitively guided instruction. Cognitively guided instruction was research done with kindergarten through 3rd grade. So it really came about in the early grades that people kind of know about using problems in context and these problem types. But there's a lot of people out there advocating that middle school and high school teachers need to know these as well and make sure that kids are being exposed to them. Okay, so I won't call people out. If you want to share what your problem type was, go ahead, but you don't have to, okay? Okay, so my chat is covering my problem type there. Good thing I have a copy of my slides here so I can read it. All right, so our first problem here is that Celeste has $7. So what I want you to do is take a look at this one just for our common knowledge, just so we can get some practice. I want you to think about, and again, you can share this in chat or not, what type of problem is this? So I didn't think this went through, but I can jump back if you need me to. So take a look at this, read through this, and then I'll go back to the problem type and chart and see if you can figure out what problem type it is. Take your guess right now. I'll go back to the chart and then you can decide whether or not you want to change your thoughts. So Celeste has $7. She gets some more money for her birthday. Now she has $15. How much money did Celeste get for her birthday? Okay. My first thing that I always tend to look at when I was first learning these was, is there some kind of action? if there is action, let me hop back to this. If there is action, it puts it in the top 2 rows. Is it a join action or is it some kind of separate action where you're separating an amount from it? So if there is action, it's going to be in the top 2 rows. If there's no action happening in the problem, then that puts it down in the bottom 2 rows. And then we got to figure out what the unknown is. So to me, that was something that always helped me categorize was, is there action or is there no action? So if we jump back to this, there is some action. She's getting more. She's getting more money, which you can like visualize that happening, right? Then the other piece is, where is the unknown? And those are the 2 things that help you determine what type of problem it is. So in this one, it is a join. There's the joining action, and the part in the middle is the unknown. So the change that happens throughout the problem is the unknown. We know what she ends with. We know what she starts with. We know the end result. We know the start. So the change is the unknown. So it's a join, change, unknown. Okay. Or some people call that an add to. I call it an add to because now I'm double checking. Like cognitively guided instruction called it one thing, Common Core called it another, and now they're mixed up in my brains. It's called an add to or a join, whichever you want to call it. Okay. All right. How about this one? Our second one is that Celeste has $15. She spends $7. How much money does she have now? Celeste has 15. She spends 7. How much money does she have now? So remember the 2 things. Does it have action? And then where is the unknown? Those are the 2 things I asked myself to figure out where it fits in that chart. So this one does have action. But what kind of action is it? Is it a joining or a separating action? And I see a lot of you in there, it's a separating. And the part that we don't know is the result. We don't know how much she ends up with after that separating action happens. Okay, so this one is an add to with the change unknown. I didn't put that part in there. And then a take from or separate. Okay, again, those are 2 different phrases. Cognitively guided instruction calls it one thing. The Common Core called it another. So sometimes I just interchange them, separate and take from. So they mean the same thing. Okay, now here's the key. The next piece of this though, how do you attach the symbolic version of this? So like, what is the equation that goes with each one of these? Okay, so take a moment and try to write the equation that would model that top problem, and then the equation that models the second problem. Okay, I'll give you a moment to do that. Okay, I'm seeing it already in the comments. I saw a few. In this first one, here's where the problem comes. Because to our children, this problem is not a subtraction problem. This problem is an addition problem with something unknown in there. That's why it's called an add to or join with the change unknown, right? When you have an add to with change unknown, the equation looks something like this. Doesn't matter if it's whole numbers, fractions, decimals, multi-digit numbers. It is something plus an unknown equals the end result, right? That's the way this problem is written. That's the way kids will try to solve it. Now the problem becomes our textbooks put a problem like this into a subtraction lesson. This is not subtraction to kids. Yes, we can solve it using subtraction, but it is not a subtraction context. And again, I won't call people out, but I did see a few people who at the very beginning, when you guys were sharing your story problems and put it into the chat, there were a couple people who wrote a problem like this, which don't feel bad. I did it so many times because I will subtract those numbers to solve the problem. But the context does not call for subtraction. And that's one of the reasons why kids struggle with understanding subtraction, is because we use problems that do not have a subtraction context. That one is an addition context with something unknown. And then the bottom one, where Celeste has $15 and she spends $7, is actually, you have 15, you're taking away 7, and we're trying to figure out how much we have left, right? That to kids is a true subtraction problem. It is 15 and we're taking away 7. How much do I have now? Okay, let's try this again. Another one. Let's see if you can figure out the problem type again. Okay. We're kind of similar, but it's because we have a little point here that I want to make. Okay. So in this one, Amir has $7. His brother has 15. How much more money does his brother have? I want you to think about what problem type this is. And if, no, I'm going to hold off on the second question. Okay. So I see a lot of compare. Okay. This is a comparison problem. Now, the comparison problems, there are different types of comparison problems. And I'm not going to go too deep into those, but I do want you to pay attention in this case, the difference between a comparison problem that requires subtraction, right? I mean, it actually, I shouldn't say it requires subtraction. Cross out my words there. Subtraction could be used to solve that top problem, right? And subtraction could be used on the bottom problem. There are two ways to view subtraction. Subtraction can be when we're comparing, and subtraction can be when we're taking from. Those are the two types of situations that we want to ensure kids understand. That is when subtraction happens, right? Subtraction can be when you compare, and subtraction can happen when you take away. Those are the types of subtraction problems, okay? Now, for sake of figuring this out and how people, if you're new to the problem types, again, this isn't a full thing on the problem types, so just really quickly, in the first one, there's no action. Amir has some money, his brother has some money. There's no action saying take away. There is no action saying put those together. It's just Amir has some, his brother has some, okay? In the bottom one, Amir has 15 and then he spends 7. Do you see that action of I have my 15 and then I have 7 going away, okay? That's the big difference. We need kids to understand that both of those require subtraction, or can have us use subtraction to figure it out. Okay, here's an example with larger numbers. And Mark just mentioned we only got 20 minutes left. I gotta hurry this up. Okay, so let's do one with a little bit bigger numbers here, okay? Just for sake of this, again, if you want to take screenshots of this to build your own understanding, okay? The top one is our comparison. The bottom one is a takeaway, right? She has some money, her brother has some money. There's nothing putting those together or taking them apart from each other. In the bottom one, Maya has 52 and then she spends 35. So some amount is actually going away. Even though both of those could be solved by doing 52 minus 35, they are very different visuals and very different concepts around subtraction, okay? So let's hop in and try to actually model these. So we are going to do a share code for the first time, but actually we're going to do it live. So I am going to hop to this. Let me see here. I need to stop sharing because I was sharing only my screen or only my keynote. And I am going to, let's go to this. Okay. And my internet is slow. Okay, so on this screen, the cool part about Brainingcamp is I can preload a lesson or something that I want you guys to work on, and then I'm able to share it with you so everything is there when you hop in. But we're going to do it slightly different because we're going to actually go live with each other. And so I need to give you the live code if my computer will cooperate. Let me, oops, let me go here. Try this. Not sure why it's just sitting there loading. Okay, there we go. Okay, so I'm going to give you this, but we are going to do it a little bit different. I'm going to do a live one. I'm going to start this live session. The cool part about going live is I copy this code. I'm going to paste it into our chat. Is now we are going to, oh, I only sent that to Mark for some reason. There we go. Okay, there's our code. And thank you, Kara and Mark, for copying that in there as well. All right, so you can go on to brainingcamp.com, click the area up at the top about share code, paste that in, and then we're able to go live. Now, do you guys see all of these coming down here? That's the cool part about live. If I just gave you a share code, you guys would all be working on your own stuff. We wouldn't be able to see it. Going live, now I get to see how you guys are modeling this. So as you hop in here, I want you to start modeling these problems. And I want you to feel how different it is. I want you to actually model that problem. Don't just pull out, don't be a number plucker, as my friend Graham Fletcher calls it. Don't just pluck out the numbers and try to do operations with it. I want you to actually follow what the problem says. Model what that problem says there, okay? And then I can take a look down here at what you guys are creating. Okay, I grabbed this. Now, in a classroom setting, what would be nice is like knowing who is who, right? When you push these. I grabbed this one really quick, just because for our sake of our time, I want to draw attention to this one because I see some people not quite modeling this exact situation, okay? So in this problem, it says Maya has 52. Her brother has $35. Sorry, Maya has $52. Her brother has $35. Take a look at this image here. Now, if you're working on yours, Mark, remind me, can they see what I just pushed, what I just loaded up? Do they have to do anything special to close out?
No, they can see your screen.
Okay, so number 17, put two separate amounts here. Does that match up with what we did in this problem, what's happening in the problem, right? Can you picture this as Maya's group of money and her brother's group of money, right? And again, yeah, the different models might be good for this, but I was trying to keep us in one certain area. So I'm going to close this out and I'm going to bring up one here. So this one. The cool part about doing this is I don't know who you are, right? That's the other cool part here. So as we see, nope, that's not the one I wanted to do. Where was it? There was one. And now I'm not finding it as things go. Okay. Nope. Where was it? There it is. Okay. Do you see how both of these are modeled the same? And again, technically, yes, they are the same problem. It is 52 minus 35. But on the one about Maya and her brother, there's actually two sets of amounts. It's not just 52, and then we're taking 35 out of that. To children, they see 52 and they see 35. And then we need to compare and see what is different between those two. So in both of these, they modeled it basically the same, right? We're cutting out the 3 10s and then we're taking out 5 1s and we see 17 left over. But this story problem elicits a different visual to children than this problem over here. And that's why we need to make sure that they're being exposed to both and that we allow kids to model them in the way that the problem actually has it. If we want kids to visualize them, we've got to let them actually visualize it. And that's the problem with the textbooks. It's not a problem that, I did it because our textbooks did it. Our textbooks would have a problem like this, and then it would tell kids, do this, then this, then this. That's not the way the kids see it, right? We need to allow space for kids to model it in the way that they are actually visualizing it. And so, yeah, some kid might just go, well, I don't need to model the 35, so I can just slice that out. I don't need to have that model, which is totally fine for that kid, right? But if we are trying to dictate the model for kids, then that's not them making sense of the problem for themselves. And when kids first start out, I'm not saying, like, as adults, yeah, this totally makes sense to me and makes sense to the majority of us. But for kids, we want them to understand that problems should make sense and that we model the problem as we actually visualize it in our real life. Okay. So one of the cool parts about this, as you guys saw, I was able to load someone so we can talk about it. I could even write things on there and push it back out to them. All of that kind of stuff. So there's a very cool function to allow us to be able to share and work together. Okay. All right. So I'm going to lock down our activity because we're going to come back and start to look at another couple things here. Okay. All right. So let me bring this back up and let's play this. You able to see my screen now again? Hopefully. Okay. So that's where we were. All right. Here's another scenario with fractional amounts for our time's sake here. Again, these are something, again, that we can model in different ways, but I'm going to kind of fast forward, give you the preview of this and say that top one is our comparison where we're looking at how much one person ran versus a different amount that another person ran. And then our bottom one is a take from where we are seeing an amount that we're kind of separating them out. Okay, so that's a version with fractions. Now we have a share code here that I didn't put. We are running a little bit out of time, but I'm just going to show you this one really quick. This one's a little bit different. Oh, I forgot that we could do a different share code in the live training. Can I do that really quick? Let me just show that feature. Right? I think I can. If I go back to this live one.
Yep, you're good.
And I hit load.
Enter the share code there.
And I'm going to enter the share code. And then it's going to load up for you guys. Nope, apparently not. It said invalid code. Oh, it copied the last code. Thank you for that. Okay. I know why, because I didn't hit, I tried to copy it here and it never works. Okay, so I need to hit share code and copy it here. And then there we go. Okay.
Just push to all participants.
Thank you for that reminder. I'll push that out. Your work is going to go away. Just a little
Select all.
warning. So it's going to go away and the new one's going to show up. And I'm going to unlock it. Maybe. There we go.
So go try to press push again. And then when you press push, press select all.
Oh, thank you.
Because you can
There we
differentiate to
go.
send to just a few.
To just a few. See, my mistake made us be able to learn there's another way that you can do it if you wanted to share something just with certain kids. Okay. So this, again, it's just another little way that you can model using these tools. This one's with fractions. And again, oh my gosh, we only have 12 minutes left. Okay. So that's one of the cool parts is when you're in that live, you don't have to share anyone. You can grab a new share code that you already had pre-made and push it out to them and all stay in the same live amount or live session so that you can see their work on this new problem here. So that fractional amount, again, it's just, again, to give you another example that this same thing applies, right? In Isabella's, most kids see that as two separate amounts. It's not the 3 1/4, and then I'm going to slice out 2 1/2 of it. They will create the 3 1/4. They will create the 2 1/2, and then compare them. Versus if we're looking at Isabella and how much she ran, that is that total of 3 1/4. But then part of the way, you know, she makes it only part of the way. So that elicits that idea of it's all in one, but then I'm going to cut some out to figure out how much she has further to go. Okay. So we're going to lock our activity. Sorry, I know you might have been in something. I can unlock it if you want to play later. But for the sake of our time, whoops, I got a little too far there. Okay. So we were there. Okay. So the big takeaway I want you to have from that one is that most kids see subtraction as takeaway, but it also is comparison. And if we only are having kids see subtraction as takeaway, or the majority of the time they're seeing it as takeaway, it's hard for kids to see the connection to addition. Okay, so let's jump into that. The last tip to help with kids who are struggling, or all kids basically building their understanding of subtraction, is to connect addition and subtraction. One of the most popular ways that is done is with the fact triangles, right? The fact families, which I'm not totally against. Like sometimes we just need practice, okay? But let's explore some other ways that we can also work on fact families. One of my favorites is through story problems and giving the same story problem, the same context, the same numbers, but different versions of that story problem, right? So take a look at each one of these. And I did the first one for you, where that first one, I think just because my animation didn't quite work right, you got the first one. But I want you to think about the next one. What equation would you use to represent that actual situation that's happening there? And then what about the bottom one? I guess there's lots of visuals that we could use for these, but what's it boil down to? Like, what is the actual equation of how we would solve this problem in the context as it's written, right? Like, as we've said before, that first one, yeah, we can pull out and say it's 15 minus 7. That would give us the answer. But the way the story problem is written, it is 7 plus something gave Jaylyn 15. And the goal is to figure out what that unknown is, what that something is, right? So the second one, I'm seeing it in there, is 15 minus 7. Now, here is my big question for you. What do you think of that bottom one? Jaylyn has $7. His brother has 15. How much more money does his brother have? What would be the equation you would write for that? I'm seeing some 7 plus somethings equal 15. I see a 15 minus 7, right? And Addie kind of hit it on the point here. It can be either one. You guys, there is no set way. Even though I said comparison really is subtraction, but you can solve any subtraction problem with addition. And this is one of those problems where kids do it. There's no action happening. That's what makes the difference. When there is action happening in those join problems and those separate problems, it's telling them add, subtract. But in problems that have no action, there is nothing in that problem that's telling them which one to do. A kid could take the $7 that Jaylin has and work and add up to try to get to that 15. So to that child, that problem is 7 plus something gives me 15. Other kids might have started with the 15 and then worked their way down, right? There's different ways that can be modeled, and that is totally dependent upon how that child saw it. There is no one way that problem needs to be written with an equation. There is a way that I see it, but there's a way you might see it. So we want to do problem strings like this, where we help kids see that, yeah, this is all basically the same problem, but in different contexts, we're using the same numbers. We're working on our fact families. We're getting to talk about how different contexts make us think differently about this problem. And then especially when we get to that bottom one, some kids may add up to do it. Some kids might subtract. Some kids might just count down from 15 to 7. Like there's lots of ways that kids will talk about it, which gives us that opportunity to then talk about how subtraction and addition are connected, but they're seeing it in real contexts. Okay, so we're still doing a fact family practice that 7 plus 8 equals 15, 8 plus 7 equals 15, 15 minus 8 equals 7, you know, all that kind of stuff, right? Yeah, so Kelly, what happens when the numbers are larger? So I did same thing. If Jaylin has 327, he gets some more, now he has 758. I still, like once I learned, okay, I don't say that I came by this naturally. I used to solve every single problem like that in like the rote way that I was told to solve that, like subtract, stack it, you know, do the algorithm, figure it out. Once I learned that you can solve any subtraction problem with addition, my world forever changed. Like, I'm not saying that to be dramatic. I was horrible at subtraction, but I'm good with addition. And so if I can think addition to solve any subtraction problem, it opens up a world to kids. And that's why it's so important that they see it in those contexts, right? So it just scrolled past me there. Let me see if I can get it back here. So with your example of Jaylin having 327, he gets some more. Now he has 758. I totally visualize that on a number line, like Craig said in the comments. I see 327 and I'm hopping up and I'm using some of my friendly numbers. Like I might hop to 350, and then I might hop to the 400. And then from 400, I can hop to 752. And I can see the difference between those two numbers. And that's actually what the definition of subtraction is. Subtraction is the difference from the subtrahend to the minuend. Right? And that's why when you're working with positive and negatives, it matters which one you start with. It is the distance from the subtrahend to the minuend. Okay. And it is the difference, right? That's what subtraction is. It is the difference between these numbers. And if you can visualize them on a number line, you can find the difference between numbers, okay? Okay. So here's an example of using number talks. How are we on time? Oh my goodness, 4 minutes. Okay. All right. So let's show one here. I love doing number talks where we just show a problem at a time. And here's an example of doing a fact family, okay, the fact family, but as a number talk where kids solve them and then work their way in. I have a share code for this also, if you want to take a screenshot and then go play with this later. I know we're kind of low on time. Again, just take a screenshot on your phone, on your computer screen here. If you want a copy of these slides, you just email me. We've got, Mark says it's okay if we go over a bit. Okay, so if you want a copy of these, just email, we'll get this to you, and these will all be hyperlinked. So you can go to them and play around with these a little bit. Okay. But basically this takes you to one where you can model these if kids want the visual picture to go along with it. Another thing that I have done is take screenshots from Brainingcamp. So this is one, I'm going to share this really quickly, hopefully. You can still see my screen, I believe. So this is in the Numberline app, and I just created these images here. And you can, in the share function, you can copy the image, download the image. I also will just take screenshots. And then basically what I did for this was I just took each of those images and then I created like a number string where we talked about, okay, so 3 to 7, what's the distance? Or actually it was a question mark there. It's kind of blurry, you can't see it, but 3, and then they're adding 4. So like this is for younger kids, right? And then what do I end at? And then this one is showing 7 to 3. What's the distance between those? Okay. And then here's one where it's 4, and then I'm adding 1, 2, 3. Where am I going to end? If I start at 7 and I go back 3, where am I going to end? So it's a series of problems that are related in some way that help me have a visual to be able to talk about these. Okay. So Catherine said, what's the difference between the subtrahend and minuend? I always need some kind of mnemonic because whoever remembers these things. But in a subtraction problem, you have the minuend is the first one. Subtrahend is the second one. It's the amount you're taking away. And then of course you have your difference, which is the end result. So minuend is the first one. Subtrahend, the only way I remember that is it's the second one in the problem, and then your difference. So thank you, Kara. So minuend minus subtrahend equals your difference. And that applies with all subtraction. So whether you're doing, even when positives and negatives, if we had other time for that, like I just learned when you're subtracting a negative, it just becomes a positive. But if you place numbers on a number line, positives, negatives, doesn't matter. It is the distance from the subtrahend to the minuend, and the direction that you're going tells you whether or not it's positive or negative. Okay. But again, that's just kind of a brief little overview on that. Okay. Okay. So let's take a look at this one. This is where we're going to end. This is one for fractions that I created a little string of problems for the kids to model. So in this one, instead of just taking screenshots, I can actually create it in here. And again, here's the share code. That was, let me jump back there so you guys can copy that share code. So jot down that share code, put it in the chat for me. And we're not going to do this live, so you can just use the direct share code there. Oops, there we go. This is our last one. Thank you, Heather. Okay, so let me hop back to this. So what I wanted to share with you on this one, let me go big here. Okay, is I pre-created this, which is always nice. And no matter what we do here, if I go back and use that same share code, it reverts back to this screen. No matter what I do here, that share code takes me back to this. So here's something where I start with 1 3/4, and then we're adding 1 1/2, and I want to know what amount is going to come here, right? And on your screen, you're able to play around, do some things, and it's not showing up on my screen, right? But if you wanted to, then that's when you go live and you can see what your kids are doing. But what I really wanted to use this for was to just show you, I have things kind of pre-made here. And I have basically I just took one of these rectangles and I covered the next problem. So when I'm ready to reveal the next problem after we're done talking about this one, then I can delete this, and now I've got my next problem here to talk about the kids. But it leaves this problem here. If I wanted to, I could cover that one up. I could bring this up here and cover it, right? I could do this and cover it. I can fill it in. And then the only thing that doesn't get covered is any of your writing there, right? But I don't want to. I want to leave it there because the whole point of this activity is that I want kids to use something we just did to help them with something we're doing right now, right? I want them to see connections between these problems, right? And then after we're done talking about this one, then I can move into this one, right? If I'm at 3 1/4, and then I go back 1 3/4. What was this amount? Or where did I start? You could see it either way. I started with some amount and then we added 1 3/4 and now we're at 3 1/4. Where did we start? Or it might be a problem, a context where we had 3 1/4 and then I took away 1 3/4. So how much did I end up with? You can create that image there. And if you notice, some of these I used the fraction, the Cuisenaire rods actually. And really quickly, these are the Cuisenaire rods, which typically, are different fractional amounts. But the cool part in Brainingcamp is I can decide what the whole is. Typically with Cuisenaire rods, the orange is worth 1, but I wanted the purple to be worth 1. So I could model this a little bit easier on this problem here. So you can change these amounts to be whatever you want them to be. I used the Cuisenaire rods in some, and some of them I just created a little rectangle to cover that area because I didn't want them to see the individual parts. I wanted them to see it as one big part here. And then they might be able to draw, take amounts and draw them over here. And then here's my final one where I'm going to put it vertical just to mess with them a little bit and see if they can attach some of the meaning and if that changes how they are able to perceive this problem, right? So it is basically the same problem over and over again. It's this fact family of 1 3/4 plus 1 1/2 is 3 1/4, but I can take 3 1/4 and subtract 1 3/4 and I should get 1 1/2, right? This fact family practice is wonderful to do in like problem strings, especially when you attach visuals and you attach a story problem to them. You put these into a context and then, man, you've got a lot of cool things happening there. So I accidentally stopped sharing, but I need to bring this back up, I think. So our last piece here is just to thank you for giving up the time tonight. I know in a crazy school year, giving up an hour of your time is a big deal. So I appreciate you taking your time tonight to be with us.